All right, so that's all for our spotlight session, and then we will gonna start our panel discussion. It's my honor to invite Karen and Siyuan to the stage, and then we have a remote online panel as well. Joohyung, are you there?
Yes.
Great. Yeah.
Okay. Yeah, I think. Yeah. Yeah, please welcome our panels. Nice. All right. Toru, do you wanna start?
Yeah, so I'll just start. So thank you, Karen, Siyuan, and Joohyung for being here today. I'll be monitoring the session. And for the panelists, our formats will be the following. So I will start by asking a general question, and then I will give each of you specific individual questions that are specifically designed for you to answer, but other people can also feel free to jump in. And at the end of the session, we will have another round of general questions. So I will start with the first question that the workshop organizers had prepared. And the question for all of you is, what do you think is the most overhyped and the most underrated direction in the research field that you work on, or we all work on? Specifically for the workshop today, whole body control and also bimanual manipulation. So whoever is ready can start.
Feel like, by the way, this is complete instantaneously. There's no preparation, right? So you didn't send me any questions for it.
Yep.
I think that I wouldn't say any of the approaches that we are delivering overnight because the complexity is not clear to me yet. So my feeling is that there's definitely some approach that people put more attention, for example, teleoperation, imitation learning, that you can consider it as overhyped, but in my mind, it's just one of the many bets that we have to put on. And so I wouldn't say any of those approaches are overhyped. But there's definitely underrated approaches that people should pay more attention to. For example, what I talk about today, I think this whole synthetic pipeline, we tried, we failed, we tried, we failed many cycles. But it doesn't mean that we should stop trying because a lot of things are different now from, let's just say, last time we tried it, maybe 4 or 5 years ago. And same thing with RL as well, right? So I think every approach that we're looking at has this life cycle. And which means that I don't think we should label anything that's overhyped or underrated because they all have their own development cycles, evolution.
Yeah, thank you for the input.
So my answer for this question is, I think I will focus on the underrated regions. So I quite agree with Karen about the real to sim to real pipeline. So basically, it's a very good method to generate data, the infinite data, and then do the sim to real transfer. And my answer will be much more focused on how to interact with the 3D world, physical world with force and tactile. So as Karen also mentioned that the calibration system is not efficient or sufficient if there is no modeling of the force of the contact and maybe tactile on the fingertips for the humanoid robot. So I think that people might need to devote more energy and resources into trying to modeling the force of different joints and maybe the tactile of the fingertips of the hand and maybe the skin force from the humanoid skin. So this will be a much promising way, I would say that, to develop a better data system. So currently we use the teleoperation system for human robot, but we cannot aware about the environment and no compliance. So it's hard to scale up. So we complain about it's very expensive to scale. It's very expensive and challenging to scale. But I believe that if we have a better modeling of the force, the tactile, and the compliance, the force, it would be much better for us to have a better system in no matter in the teleoperation or in other data pipeline. I believe that. So in our group, we focus a lot on scaling up the teleoperation system and adding the forces into this kind of system, and also in the dashless manipulation. So I would say this is quite underrated. Although a lot of researchers are moving into this field, that I would think is still underrated. Thanks.
Thank you for the insight. And now we go to Joohyung.
Yeah, so I totally agree with Karen about there's not, I don't think there's any overhype because so what we are trying to explore is a much higher dimensional space. So we need to do something like to figure out what will be the good way while we are exploring. I think as I don't think there's any overhype and underestimated. There are too many area, I think, but I can say so we've been using because of the embodiment we've been using URDF for some tree structured data format for the embodiment, and that data format is kind of unique, but I think we need to discuss more about the data format because it's the nature of the data format is not quite scalable. So how to share the data between the researchers and so there are some open data, but it's not quite compatible each other. And while we are collecting data, we actually need to discuss a lot more about the data format, which is related to the representation problem too. So I am really interested in that direction. So yeah.
Yeah, thank you all for sharing the insights and the different topics that you feel people should work on more. So now we'll start by the round of more individual specific questions. So I will start from Karen since you took the last answer first. So you did a lot of work in the past that I was a big fan of on physics-based animation, biomechanics, or other related topics. So I'm really curious, is there anything that you think from watching human whole body motion can teach us that robot-only data will never teach?
Yeah, that is a very good question. I think we're doing that already, right? Because look at how we can get robots. Just look at the previous few projects, right? We're doing all these highly dynamic, critically balanced motions, and this is all learned from human data, right? So I think just the fact that we can move so quickly now with the modern robotics hardware to to advance humanoid robotics in the last 2 years is because we have spent 20 years, or even people before me, working on character animations, on biomechanics, studying human motion with no obvious application in mind. It's just curiosity driven. And because of that, we have the infra, right? We know how to do retargeting long before humanoids is ready. We know how to do the motion capture, data collection, the best practice of that. We know how to, use RL to train policies from the data. And what's important, right? The joint angles, the partition, representations. And now we're moving into vectors manipulation, which has also been studied for a long time in simulation and biomechanics, computer graphics. So I guess to answer the question, I think you're right, and I totally agree. And then we're doing that. We're learning everything from human motion already. When will, I think more interesting questions, when will this approach hit a wall? And I think it will. I don't know when, but I think right now we're moving more towards whole body manipulation, dexterous manipulation. We're still very much depending on a lot of things we learn from simulation and models and theory of biomechanics. So not in the foreseeable future, because robots still not quite at the same dexterity or agility level that we understand. So I think this line of approach, this way of thinking, can probably give us another few years to push humanoids.
I see. So I guess related to the point of the question of when will we hit a wall, I'm also curious, what do you think on where does human motion mislead us, specifically when used as a target for a robot with a very different embodiment? Are there any specific characteristics that you observe, and how do you resolve it?
Yeah, that's also an interesting question. I think when human motion or human data mislead us, if I were to put my bet on when, I think it's when the sensing mechanism is very different. Like, so for example, robots are not constrained by the same way we observe the world, right? You can add cameras on the wrist. That's just one classic example, right? We realize that if you have wrist cameras, a lot of things are capable for robots to do. And humans don't have that. So we depend a lot on just the hand-eye coordination, and then maybe robot doesn't need that. And insist on, let's say, hand-eye coordination is super important. Maybe that will refrain us from exploring the potential strategies for robots that could be more powerful than learning from humans.
Wow. Yeah,
so I think that the biggest difference is the way they sense the world, they observe the world, like the way robots observe the world is could be fundamentally different, and could be more flexible, or because we can always add more sensors and better sensors.
Yeah, thank you for sharing
that. That would be a very different way to control gamers.
Yeah, did anyone else have anything to add on? Yeah, I think that's our great answers.
Yeah, I think so. So when I worked for Disney's animatronics is usually mimicking the characters' motion or like actors' motion as similar as possible, even though it has totally different embodiment. Its shape is almost same, but the natural dynamics is totally different. So while mimicking the human motion, it's actually not quite like energy efficient nor like a proper way to use the hardware. It's not optimal motion for that hardware, but that to mimic that motion. So animatronics is usually doing the social interaction, not physical interaction, right? But we want to use the human motion as it is in G1 or some other hardware for very dynamic motion. That will make huge problems, safety issues, and some other problems. So I think it's the mimicking or using human like data where the knowledge from the human is important, but we need to be very careful, or we need to make almost same like embodiment with human. So
Yeah, so I guess there's a combination of hardware design problem and algorithmic problems to solve.
right.
Thank you. And my next set of questions will go to Siyuan. So Siyuan, you've done a really broad spectrum of work covering a lot of things related to robotics, from perception to control. So I'm curious that for you, for a robot acting in a 3D scene that it's never seen, what do you think must be explicitly represented versus left an end-to-end policy, given that you have worked in different spaces?
So, yeah, it's a very good question. I think about it a lot. So in current region of how we develop model and develop data, I think we don't have a very good end-to-end policy for understanding the 3D thing and combine that with the motor policy. Like more in practice, we no matter in policy learning of the real to real pipeline, we use the 3D thing understanding as a tool for creating like replica of the 3D world, and then we use that maybe with Gaussian splatting to get a very flexible and efficient augmentation of data. I think it's a good way of using the techniques in 3D vision and 3D scene understanding. But I think about a lot that we are not addressing the real to scene problem at scale. So that is the essential risk I want to mention a lot recently. So basically, we have a relatively mature techniques for real to scene, including how to transfer the semantics and RGB to the real world, but we are still in lack of an efficient way to do the real to scene in scale and accurately. So this is, I think, it's still one major bottleneck in the 3D scene understanding in terms of how you can contribute to robotics. So for example, for the articulated objects, we cannot create a replica, and also the kinematics, dynamics, friction, stiffness efficiently using the current state-of-the-art reconstruction techniques, right? And for large scale of reconstruction, we cannot understand each single object. For example, there are so many chairs in this room, but if you are using some 3D reconstruction techniques, you will lose a lot of details, including the texture, the physics, dynamics, and articulation. So for me, the 3D understanding techniques can serve as a very good bridge for like duplicating this kind of 3D understanding into the simulation, then transfer to the real world. But right now it's still missed. And for your question about should we do it end-to-end or like hierarchically, I think it really depends on data scale for me. So currently the data is still limited, so we can only use the hierarchical approach to do the learning for the models. For example, we have system 0, system 1, and system 2. The system 2 can understand and parse the 3D thing, maybe use different modular architectures to understand the 3D thing. But in the future, if we can scale up, especially scale up the real to scene to real pipeline, it might be possible and more accessible for us to have a huge amount of data. I think in that sense, we can use a more end-to-end approach to learn policy, maybe directly from visual sensory input to the motor policy, rather than a practical approach, right? But bottleneck is still in the 3D part, how we can reconnect. If you have the data, we can learn either from point cloud, from depth, from auto view. I think we can train the model like very scalable. Thanks.
Yeah, that makes sense. And given that we've talked about the method, And I'm also curious about what you think about the evaluation, because I think there are a lot of people still criticizing the view, saying that we're mostly still interpolating within the training distribution for humanoid robotic control. So I wonder if you see any clear evidence of out-of-domain generalization for this topic, and also what would count for you as a convincing proof of generalization in general.
Yeah, this reminds me about Tony's answer about the research demo and product and deployment. So actually, we are facing similar dilemma in research labs. So basically, the demos are all fancy, I would say, but the actual live performance or the robustness is quite limited for maybe a majority of current works. So for me, it's really important to test the model in a very strict standard, especially for the real world robotics, a real world robot. For example, in OmniStream, we burn out a lot of the machines, Siyuan machines. We do like test for consecutive success rather than only the success rate. So in my experience, the consecutive success over a consecutive trial is really matters more rather than the pure success rate. For example, if you're using pure success rate, you may get 80% or 70% of performance during maybe 100 trials. But if you are adding the consecutive success rate, then you will maybe only get 10 or 20% of this kind of metrics. So I'm pushing myself in like using more and more rigorous the metric in evaluating the real world robotics. And I think this spirit should be expressed more in the community so people have fair comparison and especially for real world robot metric to test the generalization capability. And also for the generalizability, we have so in simulation we already have a lot of like a diverse situation, like lightning situation and object shape, this kind of testing evaluation metrics. But I would say the oversimplified situation happens more in the real world experiments. So I'm more interested in how to increasing the rigorous, the current our research works in evaluating the real world metrics.
Yeah, I guess that's a broad question that could be open to the other two panelists as well. So what do you think would count as convincing proof of generalization as opposed to just a well-chosen demo?
I feel like in academia, we have one evaluation metric that's unique to us, which is how many people can actually use your open source code to do things. And that evaluation in many ways is even more significant than achieving some success rate yourself, right? So I'll have two examples. One is the Beyond Mimic. We in open source Beyond Mimic, as soon as we know it actually works, in a success rate, I mean, it's, it really depends on so many things and examples and everything, but we know that in general.
We love them. We love Beyond Mimic.
Right, we know that it works robustly for the things we test. And actually, we still haven't published that work yet, but we know that everybody's using it already. So that to us is probably the more meaningful evaluation metric.
Yeah, that's a really good point.
And same thing with tutorial, right? We actually just published it at RSS, but that the people use our code, as soon as we're done, like as soon as the submission deadline is over. So I do feel like there are other kind of evaluation metrics that could make impact to the community than just some numbers.
Yeah, really appreciate all the open source projects.
Yeah, I have same thoughts on the hardware too. Now in academia, many of like groups are using G1, and that actually made G1 quite like useful in using same code and all the other stuff together. So really want to see more hardware deployment from the company Sunday Robotics or some other companies to sell more robot. So that's all like related to market and also politics and some other issues. So, but I really want to see more robots in just daily life.
Yeah, that's true. I guess the overall takeaway is community adoption is also a very important metric for evaluation. So, yeah, thank you. And then the last individual specific question will go to Joohyung. So the question I have for you is that so you learn a lot from on real humanoid hardware, not just in simulation. And do you find anything that a policy really learns wrong when it never touches your physical robots? Like, for
It's
example,
hard.
failures that only showed up in a motor, cable, or gearbox when they're in the loop.
So that's a hard question, but I can say recent like success in humanoid robot is use of the more like a transparent mechanism like a QDD based robot.
Mhm.
So that's actually so old days we use high gear reduction like mechanisms for the old joints and using having some kind of like transparent relationship between joint torque and from the motor that was not easy. We had to have like direct torque sensor for the joint if we want to have that one. But that made like all the joint very bulky and heavy, and that made some other issues. So it's actually related to the simulation. So current simulator is much better than old days, but it's still most of problem is how to handle like contact. That's related to the friction and the high gear reduction. So the structure and everything. If you wanna have detailed simulator, so I think as how to make like a little bit larger like QDD kind of mechanism. So currently G1 booster or the slightly smaller size robots are pretty good. But we want like human size one to do more task. And there's some limitation in using the current like component for that size. So I think that's a kind of current problem in the hardware side. And if we have good solution for that, I think we can keep using this traction, this like QDD based robot. But I think we also need to develop more like human-like mechanisms. So in nature, we don't have any like rotational joint. Well, we have rotational joint, but we don't have this rotational actuator at all.
So we have
So
muscle structure that's
right,
and scale.
right. So we also need to spend some like energy and time to develop like more like human-like or more efficient, transparent like mechanism and hardware. So that's I think
Yeah.
yeah.
So I'm also
That's the
curious,
answer.
yeah, is there any control problem, urgent control problem that you would rather solve in the mechanism rather than in the policy that you can think of?
Control problem. I think it's more related to the safety. If we wanna have actual like leg robots, I am like totally like humanoid fan. So I really wanna have leg robots, biped robots, in your word. But it's not quite control problem. So it's more about if there's any issue, power off or any like simple disconnection in the power line, or so the robot will just be down, right? So I think that's kind of huge issue in using the robot in real life. And so in industrial like robotics, all the mechanism has this the brake system in case the robot is there's some issue. Yeah, but the current like QDD based robots are not using that kind of system. So there are many things in the hardware we need to like. I don't think we need to have that part, but we need to uh, kind of consider and explore if we have that kind of like mechanism in the humanoid robot or not, because there's a difference between actual human body and the humanoid robot.
I see. Yeah, thank you for sharing the insights. And now I will have a last question that is for everyone to answer. And a question probably represent the curiosity from a lot of students. Do you think now is the right moment to start a company on whole body control and bimanual manipulation? And the rationale for this question is a lot of students are wondering whether science from academic research might already be ready or good enough for commercialization. So we want to ask what your opinion is, and if not, what is the biggest bottleneck we still have from commercialization?
Yeah, I can say it first. So my answer will be yes, because I just co-founded
Yes. Yeah, I can see that.
manipulation. So in my view, that so we are putting a lot of effort in studying the humanoid control and dexterous manipulations, and we have different pipeline or paths towards how to collect scalable data. And we are very, although there are a lot of difficulty and challenges, but I think we are quite aware of the bottlenecks, where are the bottlenecks and how to potentially solve them. But it still needs the scale, right? So no matter you want to collect data from for controller, right? I said that the controller part is underrated in current bimanual or human robot. So we can collect more data, and in terms of motion capture and forces to train a better controller, and we can use a large-scale synthetic approach to get the real to sim to real pipeline, and the real to sim part is still bottlenecked. I think although there are a lot of challenges, but the way we can do it is like under consideration for me. So basically there will be no extra magic. I would say no extra magic for the robot. And this is the first reason. And the second reason is that I think the hardware is almost ready for really getting a robust and generalizable humanoid foundation models. Although the GR robot, the payload is still limited, right? The actuator, they hit it a lot during the implementation and during the deployment. There are still a lot of problems, but the consistency and robustness is almost to the threshold of comparing different models and developing robust models. So I would say right now might be a good moment for us to really get more serious into doing all this kind of dirty work in data collection, data filtering, and also the co-involvement of hardware and software system. I think I mentioned one point I would very acknowledge is that the real humanoid robot might share different hardware setup with humans, but that requires a lot of hardware and software co-design. For example, I was obsessed with the active vision problem once in a while in my PhD study. But right now we are testing a lot of models and also the VLA models. It seems that the humanoid robot may not need a 2 degree of next and may not need real active vision system like humans, because you can have a panorama cameras and you can have a fisheye cameras with huge degree of freedoms, different camera setups, similar to the tactile and how we sense the forces about environment. And it requires a lot of iterations between the hardware and the software. And I think a better and more efficient iteration may happen in industry that would be better suited for the industry people. So I would say yes towards this question. Thanks.
Yeah, thank you for the input. I think others might have different opinions. So
I guess I'll have the different opinions.
yes, please.
If you say yes, I'll say no. But I think you'd be surprised at how many students ask me this question in my office, like, am I too late? Am I too early? Is it just the right time? And I feel like you can argue any way you want, right? Because it's just not clear, depending on what your idea is, whether it's too early or too late, or just right in time. But if you ask me, and this is a very personal opinion, I don't want people to take it as advice. I would say no, because I haven't figured out the data problem and how there are just so many, like I said earlier, I cannot give up on any approach in terms of data generation. I think I need to put that on teleoperations, UMI, video-based, synthetic physics simulation, all of them. And before I figure out which one is more promising, I feel like it's too risky. Like, I'm a very conservative person.
So my question is, eventually, would you have a bet?
I think we will probably have multiple successful bets at the end. That's my hope. And then there's always this belief that, oh yeah, everything we just have a co-training with a different that, and that could be true. But just like if someone gives me unlimited resources right now to put bets on everywhere, I think that's what we'll do. And then until I figure out that there is a few bets that are going to be successful, I probably would not start a company using my own money. Maybe.
I'm sure Stanford is a great place to do it.
And I have so many students that are in a similar situation. They want to finish earlier, or not finish at all. Stanford's famous for our dropouts, right? So yeah.
Yeah, nice. What about your opinion, Joohyung?
I don't know about the timing. If I knew that, I could make lots of money. So yeah, but there's a famous saying like pessimist on fame, optimist on money. So risk is high, but I think there's some chance for students. So frankly, the problem we are trying to solve is very hard problem. I'm not saying this can be solved like easily within a decade, meaning it's more about like timing. If so start company is if that goal is just making money, I am not sure about that, but there's always problem we need to solve, and in current like academia in US SF, getting funding is not easy anyway. So maybe there's some chance to just start a company to solve some interesting problem. Yeah, that's my answer.
Nice. And thanks for sharing the old saying.
Yeah.
That's first time I heard it. And yeah, so with that, I would like to thank all the panelists today for joining the workshop and joining the panel. I personally learned a lot. I hope the audience also learned a lot. So I think now Yongwon and Ziwen will wrap up. And for the remote audience, we'll also wrap up the Zoom session in a few minutes. But thank you all for attending. Yep. And
Thank you very much. Yeah, we are very, very behind the schedule. So, but thank you for patience and thank you for all joining this workshop. We will probably, yeah. I hope you guys have time to discuss more afterwards, and we will probably see you in next fall, maybe, or next RSS.
yeah,
All
we'll
right.
see you. Yeah, enjoy the conference and see you all.
All right. Thank you very much.